Hello guys, welcome back to my channel Medicinal Pharma Education. I hope you are doing well and preparing for your exams, and we have started with the chromatography chapter and completed the paper thin layer and ion exchange, and in today's class we'll complete the column chromatography. Okay. uh, the column chromatography, we'll start with the definition of chromatography. uh, M. Sweet Twist Sweet 1906 defined chromatography as the method in which the components of a mixture are separated on an adsorbent column in a flowing system. Okay. Next, it's not that important. Let's start with the column chromatography. Column chromatography is a separation technique in which components of a mixture is separated by using a glass column packed with stationary phase and a liquid mobile phase flowing continuously through the column. See, through the definition you can understand. Here we are using a glass column, okay, which is packed with the stationary phase and liquid mobile phase continuously flowing through the column. Okay, by this can you tell the principle behind it? Okay, just comment and tell me. Okay. See, the separation technique in which the component of mixture are separated by using the glass column packed with the stationary phase and the liquid mobile phase flows continuous through it. By this the separation occurs. Okay. The stationary phase may be solid or liquid, uh, supported on a solid or a gel, packed in a column. It is column chromatography. If see, what is the difference between other chromatography and column chromatography? If it is packed in a column, it is column chromatography. It is spread as a layer on the plate, then it is TLC. Okay, distributed and a liquid film, then it is gas chromatography. Okay, that's the basic difference. Okay, the mobile phase may be liquid, solvent, or a mixture of solvents or a gas. Okay, this is the uh, mobile phase used. Okay, in this according to this. Okay, next let us know the principle of column chromatography. Adsorption is the principle of column chromatography. A solid stationary phase like silica gel and the liquid mobile phase is used. In column chromatography, the interaction between adsorbent and the components is usually reversible. The separation is based on the based on different in the affinities towards the stationary phase. See, I said you right. The principle, if it is solid and liquid, if the stationary phase is solid, then it is adsorption. If the stationary phase is liquid, then it is partition. Liquid it is partition. Solid liquid it is adsorption. Okay, because it is surface based. Okay, in this the interaction is reversible. Okay, it does not permanently bind to the separation mixture. Okay, it is reversible. Okay, after a time it leaves the mixture, and it is based upon the affinity towards the stationary phase. Almost every uh, chromatography technique is based upon the affinity towards the stationary phase. Okay, this is the principle. I hope you have understanding. I hope you are understanding the concept. If you're not understanding, or my explanation is not up to mark, you can comment so that I can improve in the next upcoming videos. Okay. uh, these components which have greater affinity towards stationary phase will move slower rates when compared to the less affinity. See, if we have strong attraction to someone, we will lose them, uh, for we will keep them for a long time. If we have less attraction, we will lose them faster. Okay, this is the simple example. Okay, that's way in that way the mixture is separated. Okay, based upon the affinity towards the stationary phase. Okay, now column characteristics and selections. See, these are the some important methods or the materials required. Okay, first, material for construction: good quality neutral glass, plastic or nylon. Okay, next, adsorbent, stationary phase or adsorbate mixture, weight ratio 30:1. Okay, we need 30:1 ratio, it should be there. Next, column length, column length to the diameter ratio. It should be like 15 to 10, 15 to like 10 to 15 uh, is to 1, or 30 is to 100 is to 1. Okay, the column length would be like 15 to 10 is to 1, or 30 to 100 is to 1. Means the length is very long compared to the diameter. Okay, multiple compartment system is present, long column. If multiple compartments is present, then we should like use long column. Oh, sorry, multiple component system is present in long column. Components with similar affinity for adsorbent as present are present, then it is long column. Components with different affinities for adsorbent is present, short column. See here we are selecting the column based upon the components. Okay, not compartment, sorry, I have like mispronounced it. Okay, if the multiple components are there, then the column should be long. Of course the column should be long. Okay, if we are like dealing with like 10 mixtures for separation, the long column should be like very long. Okay, if similar affinities means like if we take in values. Okay, if we convert the affinity into values, if a compound has like affinity of 97 and another compound has like affinity of 96, then we should like take a long column so that the difference between those two can be separated. If we have different affinities, like the number of number, if we compare with the number, if it has one has 97 and has one has 57, then like short column is enough to separate them. Okay, based upon that we select the column. Okay, next, stationary phase in the column chromatography. Stationary phase used in the column adsorption chromatography is known as adsorbent. See here, the stationary phase is called as adsorbent. Okay, remember this word, this is very important. Next we will study with the ideal requirements of the solvent or the adsorbent. They must be insoluble in solvents or mobile phase, chemically inert. They should not react with any other mobile phase or the mixtures. Colorless to facilitate absorption of zones. Okay, it should be colorless so that we can absorb the zones or the separation layers. Should have reproducible properties from batch to batch. Okay, the if you are doing one experiment in one day, and it has some results, and the next day we are doing the another experiment. Okay, they should like another experiment means same experiment, but on another day it should give the same result. Okay, means reproducible, means the mobile phase should be consistent. Okay, it should like show the same results consistently. It is called reproducible property. Okay, the particles should have uniform size distribution and have spherical in shape. Okay, particle size 60 to 200 micrometer, I think so. A commonly used chromatographic adsorption is silica. Okay, commonly used, it may be in the TLC we use silica. Here also silica. The plot of equilibrium concentration of the species in the solution and that of amount of adsorbed is called as adsorption isotherm. Okay, here is a like a small representation of the column chromatography. Here we will be placing the solvent mixture of components here, and the adsorbent, which is stationary phase, and glass wool. Okay, to prevent the adsorbents to pass through. Okay, and which allows the mobile phase. Okay, this is the plug which is used to like separate, I mean pass the mobile phase. Next we'll study about the mobile phase, different types of mobile phase. We have like studied about the like stationary phase. Now mobile phase acts as the solvent to introduce the mixture into the column as a developer to develop the zones for separation, and as an elute to remove the pure compounds out of the column. See here, mobile phase is nothing but with the which uh, moves through the stationary phase. Okay, through, I mean through, not on the station, flows on the stationary phase, where it carries the sample through it. Based upon the attractions towards the stationary phase, the sample like is separated. Okay, here the increasing elution property. Okay, these are the lighter ones, these are the heavier ones. Okay, this is very important. In the next you will understand why I have written this increasing order. I'll just read out the liquid petroleum, hexane, cyclohexane, carbon disulfate, benzene, toluene, chloroform, acetone, alcohol, organic and inorganic acids. This is the increasing order. Okay. Next, uh, preparation and packing of column. Preparation and packing of column. Wet packing. There are two type of packings. You know, right? Wet packing and then dry packing. Okay. In wet packing is like, it is like in tablets you study, right? uh, wet wet compression and decompression, it's like similar to this, similar to that concept, it is also similar. Okay, the adsorbent is suspended in a mobile phase. The adsorbent is suspended in mobile phase and stirred very well to remove the air bubbles. The resultant slurry is then poured into the column. See, here we are mixing the stationary phase and mobile phase, and we are mixing it thoroughly to remove the air bubbles and pour into the column. At the bottom position of the column, a piece of glass wool or a cotton or a Watchman filter paper must be added before the slurry application. Okay, before pouring the slurry, we will add like the plug, what we will call like, which prevents the mobile phase to pass through it. It is called cotton. It may be Watchman filter paper or a glass wool. Okay, after slurry after slurry application after slurry application, the column must allow to settle overnight. This is an ideal method for column packing. Okay, this is like wet means we are like mixing the stationary phase and the mobile phase and transferring to the column. Then we are introducing the sample. Okay, and next, in dry column, you can like guess what is the dry column. Where I kept the paper. Okay, where it is. Get, where did I keep it? Kept it here. Okay, I got it. Next, dry packing. In this method, dry adsorbent is on poured to the column directly. Here, the dry adsorbent, what's the stationary phase, is directly poured into the column. Okay, vibrations are applied to get rid of air bubbles. Then the mobile phase is passed through the adsorbent. Here, firstly we will like slowly add the stationary phase. Okay, and vibrations are applied to remove the air bubbles. Okay, the demerits with this method is that the air bubbles are entrapped between the mobile phase and the stationary phase. This method cannot be applied for in gas chromatography. See, dry packing is cannot be applicable for gas chromatography because the air bubbles are entrapped in the column, and this makes the this makes the impact on the result. Okay, there is like big deviation in the result because of the air bubbles. Okay, this is the like demerit. Mainly we use wet packing. Okay, next we'll start with the sample introduction in the column. Wet application, first dissolve the sample in the initial mobile phase and apply by the pipette to the top of the bottom. Okay, next, this is very good method, but in most of cases the sample is not soluble initially in the mobile phase. See, firstly what we will do, we will take the sample and dissolve in the like small amount of mobile phase, and by the pipette we will like mark the sample onto the like top of the bottom is bottom of the column. Okay, we will mark it, and this is very good method. This is very good method, but in most cases the sample is not soluble in the mobile phase. That's the like major problem. Okay, then dry load. Dissolve sample dissolve sample in any volatile solvent. The sample solution is then adsorbed on a small amount of adsorbent and the solvent is allowed to evaporate. The dry adsorbent loaded with the sample is then applied to the column. Okay, see here, uh, the sample we take, right, we will dissolve in the mobile phase. Okay, like we'll take the mobile phase where the sample can be dissolved. Okay, that the sample solution is then adsorbed onto small weights of adsorbent and the mobile phase is allowed to evaporate. After that, same, it is like principle of same, the principle what in the TLC is involved, same here also we are doing. Then it is dried and it is loaded into the column. Next, development of column. Okay, there are many techniques, but I have written elution analysis. In this, if the individual components of a mixture are separated by eluting the column with fresh solvent, then this technique is called elution analysis. Here elution analysis is nothing but we are using an fresh solvent. Okay, fresh solvent for eluting the column, then it is called elution analysis. It's very simple. Okay, for successful separation, the components of the mixture must show different degree of affinity. See, in every separation principles, the affinity should be different. If the same affinity are like we are trying to separate, it is very difficult to separate using the chromatography technique. So the solvent or the mixture, I mean not the solvent, the mixture should have different affinity towards the stationary phase, so it is like easy to separate. For a solid support, and the interaction between the adsorbent and solute must be reversible. See, and it should be reversible, I no need to explain. Okay, I have already explained it. As the adsorbent is washed with a solvent, various components will move down the column and are arranged in their order of affinities of the adsorbent, affinities for the adsorbent. See, like based upon the affinity towards the stationary phase, they are arranged. Okay, these with the least affinity is eluted from the column first, than that with a greater affinity. See, I have said, right, if you have some affinity towards something, the time period for that is longer than the less affinity one. If you have less affinity towards a person, they we will just ignore them. If you have more affinity towards a person, we will try to maintain a relationship, I mean time period. We'll if you are just giving an example. Okay, if you are more affiliated towards a father than a stranger, that's the common example you can take. That's the best example. Next we have isocritic and gradient elution. Okay, here we have two types of elution techniques. In this elution technique, the same solvent composition or solvent of a sample polarity is used throughout the process of operation. Example, chloroform. Here we will use only one solvent. Okay, one mobile phase. Okay, that is chloroform. It is called isocritic elution. Okay, in what is a gradient elution? In this elution technique, solvents of gradually increasing or increasing elution length are used during the process of operation. Here the gradual increasing in the elution length or the polarity is used. Okay, initially benzene, chloroform and ethyl acetate, so that I have said you right, their polarity, why the increasing elution power is why important in the previous page. Okay, here it is the importance. Gradient elution, we will use the increasing elution length. Okay, we will in gradient we'll use different mobile phase. In isocritic we'll use single. By this we will complete the development of column. Next, detection and recovery, it's simple. you just read it out. Okay, we'll just collect it, and by using different techniques we will just analyze them. Okay, just read it out. You just pause the video and just read it out, because the video becomes longer. Okay, next, the factors affecting. It's all simple. The factors affecting are particle size of the solid, column dimensions. Okay, next, column temperature, solvent flow rate. Okay, next, conduction of adsorbent, concentration of solvents. Okay, next we have applications. Okay, just pause it and write it down. Okay, by this we will complete the column chromatography. In the next video we will start with the gas chromatography, and HPTLC, and then affinity. Okay, I have written the notes, and videos will be uploaded frequently. Okay, thank you guys for watching. If you like the video, just please comment it, and please subscribe, guys. It's very hard to write the notes, then make the video and just upload. Okay, thank you guys. See you in the next video. Bye.